The grade 12s as well as grade 11s. So we are going to look into question 1 for paper 1 mathematics, which is always on algebra. Okay, so 1.1 up to 1.4 is your algebra, different concepts under algebra. So as you move from 1.1.1 up to 1.4, you need to know what specific concept you are dealing with. For an example, in 1.1.1, that is your simple factorization as well as solving for x. 1.1.2 is your quadratic formula. Remember, immediately they say correct to 2 decimal places. It means you cannot factorize that trinomial. Okay, and then 1.1.3, here we are dealing with your surds, which are irrational equations or irrational numbers. Okay, then 1.1.4, here we see a greater than or equals to, meaning we are dealing with our inequalities. All right, then 1.2, we are dealing with exponents. All right, as well as solving for the unknown. Then 1.3, we are dealing with our nature of roots. And then 1.4, we are dealing with simultaneous equations. Okay, now let us start. 1.1.1, we are told in 1.1 to solve for x. So the first thing that we should do is x plus 2x minus 1 equals to 0. Since one side is equal to 0, meaning we can equate each of the factors to 0. So x plus 2 will be equals to 0, or x minus 1 will also equals to 0. Therefore, the value of x will be x equals to minus 2 or x equals to 1. All right. Then 1.1.2, we've got x squared minus x equals to 5, and we are told to correct to 2 decimal places. This is a hint that you must use your quadratic formula. Okay, so when you go to 1.1.2, that by transposing the 5 to the left hand side, this is what we call the standard form. This is the standard form of the equation. And then we know this is our quadratic formula. This is found on the back of the question paper information sheet. And then we just substitute the direct substitution. So equate each factor to 0. Okay, then we'll be having x minus 11 equals to 0 or x minus 4 equals to 0, and therefore our x values will be x equals to 11 or x equals to 4. But remember, when we are dealing with sets, you must always go back and check your answers, whether they are valid or invalid. Okay, so when I substitute 11 where there is x in the original equation, I'm getting 7. Okay, but when I substitute 4 in the original equation on the left hand side, I'm not getting a 7. Okay, rather I am getting a 1. Okay, because it will be 4 minus square root 5 plus 4. 5 plus 4 is 9. Square root 9 is equal to 3. 4 minus 3 is 1. So 1 is not equals to 7. Okay, hence I must now tell the marker that x equals to 4 is not applicable. Therefore, x is equals to 11 only. Alright, now let us go to 1.1.4. 1.1.4, I've got 4x squared plus 1 greater than or equal to 5x. This is an inequality problem, and of course we start by writing the equation in the standard form. So we start by transposing the 5x to the left, and it becomes minus 5x. Now it's in a standard form. We factorize, look for factors that multiply to 1, add or subtract to minus 5x, but don't forget our a in this case is not 1. Therefore, you must be careful as to how you factorize. Okay, so I have 4x1 and I've got x1. Now, since the value of c is positive, it means I'm going to have the same signs, and the signs will both be negative. Okay, now I have my full factorization. What do I do when I'm dealing with inequalities? I'm changing greater than or equals to 0 to equals to 0. Then I solve for x, right? And by so doing, we are finding what we call our critical values. So my x from here will be 1 over 4, and then my x from here will be equals to 1. These are my critical values. Okay, now I go to a number 9 and I put my critical values in ascending order, and then remember this sign here means included. Okay, and this is the shaded dot which stands for included. Okay, so it means 1 over 4 and 1 are both included. And now, according to this inequality, we are looking for where we are getting a positive. Okay, so where are we getting a positive? We are getting a positive to the left of 1 over 4, as well as a positive to the right of 1. How did I get those? This is a simple way of doing it. Okay, substitute a number that is a integer lower than 1 over 4, then an integer between 1 over 4 and 1, then an integer next or bigger than 1. Okay, so what I've done, I've substituted I've substituted a 0. Okay, so when I put a 0 here and a 0 here, I see that my answer becomes a positive, because it will be 0 minus 1 times 0 minus 1, which is minus 1 times minus 1, and I'm getting a positive. Okay, and then between 1 over 4 and 1, I've substituted a half. So if you put a half here and a half here, you get a 2 minus 1 and a half minus 1, of which here it will be positive times a negative, and I'm getting a negative. Okay, then an integer bigger than 1 will be 2. So when I put 2 here, I get 8. Minus 1 is 7. Then here, if I put 2 minus 1, it will be 1. So positive times positive, then I'm getting a positive. Alright, now I go back. I said I'm looking for where I get a positive. That's why my arrows are moving to the direction where I'm getting a positive. Okay, now let's write our answers. Where is this solution from? This solution is from negative infinity a smaller negative value up to 1 over 4, where 1 over 4 is included. Okay, so how do we write it? We say x is an element of from negative infinity up to 1 over 4. But remember, only infinity, in this case, negative infinity will have an open bracket because it's not included. But 1 over 4, remember, this means it is included, hence square bracket. Okay, and then O, meaning we have another solution again. Where is that solution? The solution here in this case is from 1 up to positive infinity. Okay, so we start from the left going to the right. So from 1 up to positive infinity. But what you should notice is 1 is included, but positive infinity is not. Hence, we use square brackets for 1 and open brackets for infinity. Okay. Also, represent your answer in this set builder notation. Okay, you say in 1.2, we are given P, and P is all of this. And we must simplify P. After simplifying P, then we must show that our simplification will end up being P equals to 8 multiplied by 3 minus 4. Now, since there is a minus between the terms, fine. Okay, so these are the parts that we are left with. A squared minus 16, and then remember here we can keep expression B, which will be A, and then we end up with A plus 4A. Keep them time. Remember A squared minus 16 when factorized, and then what over A plus 4 A minus 4 plus 4 A. 4 over 8 plus 4 A plus 4 A minus 4 plus 4 A plus 4 A plus 4 A plus 4 A minus 4 plus 4 A plus 4 A plus 4 A minus 4 plus 4 A plus 4 A minus 4 plus 4 A plus 4 A minus 4 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 plus 4 A minus 1.22. Where there is p, we must put 0. And remember, p was here. Okay, hence there's a 0. And then this is already factorized. Therefore, we're going to say a is equals to 0 or a minus 4 equals to 0. You equate each of the factors to 0. Therefore, a is equals to 4 or a equals to 0. Okay, and then having said that, we are now doing 1.3. They want you to prove that the roots of this equation are non-real. Okay, remember, for non-real roots, that is when your delta, your discriminant, will be negative. So if the discriminant is negative, then it means the roots of the equation will be non-real. Okay, where a and b cannot be equals to 0. Now, let us do that 1.3. So this is the given equation, of which the a squared represents a, ab represents b, and plus b squared represents c. Okay, so when we write down our discriminant, this is the discriminant. The discriminant formula, which is taken from the quadratic formula, and then we substitute. We said our b is the ab, and our a is the a squared, and our c is the b squared. Then ab all squared is ab all squared, but minus 4a squared times b squared, since they have the same exponent, we can group them and raise them to the same exponent. So it will be ab all squared. But this and this are like terms. So ab squared minus 4ab squared is the same as 1 minus 4, where we are getting a minus 3 ab squared. What do you notice? We have a negative. That means delta is negative. Okay, so since delta is negative, we say less than 0. That means the roots are non-real. Okay, that was simple. The roots are non-real for all real values of a and b. Done. Okay, nature of roots. Now let's go to 1.4. Simultaneous equations. This is like finding the point of intersection of this function and that function. That is what simultaneous equations are all about. We are finding the point of intersection. Now, remember, you must have one equation and the other equation, but one of the two equations must have one of the variables as the subject of the formula. So from this equation here, I've made my x the subject of the formula. Then I called this equation number 1. Okay, and then this was the second one which was given. I've called it equation number 2. So now I'm going to substitute equation 1 into equation number 2, meaning wherever there is x here, okay, wherever there's x here, I'm going to put 2y minus 3. Okay, that is very simple. So I've done that here, and then now I've expanded, which brings me here, and then lastly it's simplified to this. Okay, so this is what we call the standard form, which please make sure you have it. So 2y, okay, that is 2y squared, not 2y. It is 2y squared minus 3y plus 1. That is the standard form. And then these are factors, which are 2y minus 1, y minus 1, all equals to 0. So since one side is equals to 0, I can equate each factor to 0. Okay, I can equate each factor to 0. Therefore, the answer will then be y equals to half or y equals to 1. Then since I have both values of y, now I can find the values of x. By substituting back into equation number 1, I've used equation number 1 because equation number 1 was already in terms of x equals to. So when I substituted the half, which is the first y value, I found my x value to be a minus 2. Then when I substituted 1 in equation number 1 here, and then I found that the x value is a minus 1. Okay, so simultaneous equations are very, very simple because they actually afford you a chance of getting 3 marks. These simultaneous equations are normally ranging between 5-6 marks. So these are like giveaway marks. Actually, the whole of algebra, you must get 25 out of 25 or 28 out of 28. Just make sure you master your algebra. These are your giveaway marks. Okay, well done and good luck.